Okay, we're going to continue on with this exam review, and we're going to do questions 11 through 16, hopefully. And what I'd like for you to do is take a look at question number 11. It is a solve for the value of x. And when you have a radical, you have to use the IRS method, and that's isolate, remove, and then solve, and then of course you have to check. So being that this minus x right here is outside of the radical, we're going to have to add it to the right-hand side. And that's going to isolate the radical, x plus 3, and I'm going to be left with x plus 1. And now we're going to remove the radical, and to remove the radical you want to square it, and what you do to one side do to the other. And this square and this square root lift off because they're inverses of each other. And here's where we make the fatal mistake. This is not x squared plus 1. This is x plus 1 times x plus 1, which when you FOIL this out, and you can do this off to the side, you get x squared plus 2x plus 1. And now we have a quadratic equation, and quadratic equations are solved by setting it equal to 0 and using a variety of methods that we learned in Chapter 5. So I'm going to begin by setting this equal to 0. I'm going to pull everything over here to the right-hand side. And my new quadratic equation is this right here. And probably one of the easiest way to solve quadratic equations is to see if you can factor it. So are there factors of 2 that equal 1? Well, 2 times 1 is 2. To get that to equal a negative 2, you're going to have to, one of these are going to have to be negative. Now notice the value of x is positive, so our higher number is going to have to be positive and our lower number is going to be negative. So when we factor this, first values are x, because we need to get that x squared. Our second values are 2 and 1, because we need to get that negative 2. And as we've already looked at over here, we're going to get and have a minus 1 and a positive 2. You can FOIL these out to make sure you wind up with this. And of course you do. And now x, using the zero product property, if two numbers multiply out to equal 0, one of these numbers has to be 0. So in that case, x would have to equal 1 or negative 2. And there's your two answers for question number 11. Now what you want to do is you want to run these answers back through the problem to see if they check, because remember we could have extraneous solutions. So let's start with the 1. 1 plus 3 gives me 4. The square root of 4 is 2. Let me put that 2 over here. And when I subtract 1, I'm supposed to get 1. And so that one does check. Let's try the negative 2. When I run a negative 2 through that radical, that's negative 2 plus 3, that gives me the square root of 1. Minus a negative 2 is supposed to give me a 1. Okay, so here I'm going to take the square root of 1, which is 1, minus that negative gives me plus 2 equals 1. And folks, I'm sorry to say, but 1 plus 2 does not equal 1. And so this one is an extraneous solution. The negative 2 is an extraneous solution. So my only answer for this one is the value 1. Let's take a look at 12. In number 12, you are being asked to, I believe, find the discriminant. Yeah, state the discriminant. So before you can state the discriminant, you must get it in standard form, which means you got to pull that 9 over here and set it all equal to 0. So when I do, I get 2r squared plus 8r. When I subtract the 9 from this side, I'm going to get plus 8 equals 0. And the discriminant is the part underneath the square root sign of the quadratic formula, which is b squared minus 4ac. So let's look at our ABCs. A is equal to 2, B is equal to 8, and C is equal to 8. And when I apply it to this little formula, I'm going to square that 8. That's going to give me 64. I'm going to subtract off 4 times 2 times 8. And this gives me 64 minus 8 times 8, which is 64. So that gives me the square root of 0, which is 0. Now, this is the discriminant. The discriminant describes the roots. This tells me I only have one real root. Let me give you the picture here. This is a parabola. It only touches the graph in one location, and that's at the vertex. So there's only 1, 0 of that function. Okay, let's take a look at question number 13. In question 13, you're asked to solve this equation using the quadratic formula. So once again, what you have to do is you have to get it into standard form. So I'm going to pull that 2 over to the left instead of equal to 0. And once again, I'm going to use my ABCs to find out what those are, because those are what I'm going to need for the quadratic formula. A is 1, B is 1, C is negative 2, and those are obtained from the leading coefficients and the constant. The quadratic formula is negative b plus and minus the square root of b squared minus 4ac over 2a. And when I plug those in, I'm going to get negative 1 plus and minus the square root of 1 squared, which is 1, minus 4 times 1 times negative 2. And this is over 2a, and a is 2. Or a is 1, so the denominator is 2. And now when I clean up that radical, I'm going to get negative 1 plus and minus the square root of 1 minus, or actually that's going to actually be a plus 8. So that's going to give me a 9 over 2. The square root of 9 is 3, so that gives me negative 1 plus and minus 3 over 2. And I need to break these out into two separate answers. The first answer is negative 1 plus 3 over 2. And the second answer is negative 1 minus 3 over 2. And that is obtained because you have that plus and minus there. This is equal to 2 over 2, which is 1. And this is equal to negative 4 over 2, which is equal to negative 2. So those are your two answers. All right, so let's take a look at 14. 14 is fairly simple. They're just asking you to find the value of c that completes a square. Well, in order to complete the square, you have to take half of b and square it. Well, b is 22. So half of 22 squared is 11 squared, or 121. So that's your answer for number 14. And number 15, we're trying to find a polynomial function has these zeros. Find all the additional zeros. So this goes back to the imaginary root theorem and the irrational root theorem, which states that if you have an imaginary root, then its conjugate is also a root. So the conjugate of negative 2 minus I is negative 2 plus I. So that's one of your additional roots. And your second one, if you have an irrational root, 2 plus 2 times the square root of 2, then its conjugate, 2 minus 2 times the square root of 2, is also a root. Okay, and that leaves me with question number 16. And 16 is much like one we've done before, so I'm not going to go through a full explanation on this one. You can refer back to the last video. This is going to be x plus 3, x plus 4, and x minus 1. And when you multiply all these out, you are going to get the answer x cubed plus 6x squared plus 5x minus 12. And that's going to give you your answer. And that concludes this video.